Hello everyone. Uh, Today we will see about the measures of association, which is chapter 7 or unit 7. So the measures of association. In the measures of association we will see about the odds ratio, relative risk, attributable risk percent, population attributable risk, and population attributable risk percent. So this is, we will see all measures of association, measures of strengths of association. So we will see all these parameters in this chapter. So lecture outline, so we will cover relative risk, odds ratio, attributable risk percent, population attributable risk, and population attributable risk percent. So we will see all. Most commonly we will use odds ratio and relatively, but we will cover also this one. And this is learning objectives. So you can see it. So measures of association. Now we are starting. Measures of association is very important to test presence or absence of association, to test whether the association is significant or not. This is maybe we use Z test, T test, chi-square test. But measures of association, we will see strengths of association. Strengths of association is measured commonly by odds ratio and relative risk. Odds ratio and relative risk. So measures of association. An association is said to be exist between two variables when changing one variable parallels or coincides with changing in another ones. So to say association exists when there is one variable changes, the other variable will be changed. So if this one changes, the other also follows to be changed. So we can say association is present. An association is said to be causal when it can be proved that by different means, by measuring evidence or by using Bradford-Heath criteria. So to be causal when it can be proved that changing in exposure variable produces changing in outcome variable. So when the exposure variable, change in exposure variable will make change in outcome variable. So this change also, this real, whether it is a real change or not, will be proved. So if it is proved, we can say causal association, or we can say the association is causal. So more appropriately, causal relationship exists when exposure enters into causation of disease. So a causal association exists when risk factor causes change in the disease. So this is causal. So measuring an association quantifies the strength of relationship or the strength of association between an exposure and outcome variable, outcome of interest or outcome variable. So by what is the strength between the exposure and outcome variables? So it will quantify this one, and also it quantifies the difference in occurrence of the disease or days between two groups of people who differ on exposure status. So also will quantify just the difference between two groups which differ on exposure status. That means what is the occurrence of disease among exposed minus among non-exposed. So this is also will be done on the measuring association. So now the very important point is that the strength of association is commonly measured by 1. Relative risk, 2 is odds ratio, 3 attributable risk, 4 attributable risk percent, 5 population attributable risk, 6 population attributable risk percent. So all these are commonly used measures of association or measures of strength of association. So now we will see one by one. Now we are starting relative risk. Relative risk is symbolized by RR, capital R, or we can say risk ratio. So relative risk shows the magnitude of an association between exposure and disease. By what magnitude? By what amount is association present between exposure and disease. So shows the burden or the magnitude of an association between exposure and disease. It indicates the likelihood of developing the disease in an exposed group relative to those who are not exposed. So the likelihood, the probability of developing one's disease in exposed group as compared to or relative to those who are not exposed. Relative risk can be also be used to compare risks of death, injury, other possible outcomes of exposure. So relative risk is we will see how relative risk will be calculated. So this is disease develops, disease is not developed. So this is exposed, non-exposed groups. This is diseased and non-diseased groups. So we can say we can draw 2 by 2 table. This is A, this is B, this is C, this is D. So A plus B is A plus B, C plus D is C plus D. So in total. So if you want to calculate incidence of disease, A over A plus B is an incidence of disease. So C over D, C over C plus D. C plus D is an incidence of disease. That meaning, for instance, A means the probability of disease develops in exposed over the total. Is incidence of disease of the disease. This one is the incidence of disease in an exposed group is over C plus D is incidence of disease. So A over A plus B is equal to incidence in exposed. This is incidence in exposed population. Incidence of disease in exposed population. The incidence in the non-exposed group. This is also C over C plus D. C plus D is incidence in incidence of disease in non-exposed population. So you can say you can calculate incidence in exposed by using this formula, incidence in exposed by using this formula. But these two things are also important to calculate relative risk. So relative risk is we can divide A over A plus B over C over C plus D. So A over A plus B, C over C plus D is a formula for relative risk. So you can convert it. So we can get is this is the formula for relative risk. In number, when you see in number, for instance, this is individuals who develop coronary heart disease. This is not develop coronary heart disease. This is exposed for cigarettes. This is group is not exposed for cigarettes. So among exposed who develop the disease 84, among those who are not developing the disease that exposed for cigarettes is 2,916. So this is 3,000 is total, and also 5,000 is total. So incidence of disease in exposed population is 84 over 3,000, and also incidence in non-smokers is 87 over 5,000. So relative risk is equal to 84 over 3,000 over 87 over 5,000 is equal to 22. By this, the answer is 1.261. So the relative risk is 1.61. The relative risk is 1.61 is the relative risk. So we will see this one. So how to interpret it? This 1.61. How to interpret it? So the disease or hazard related outcome is 1.61 times more likely to occur among exposed to the suspected risk factor. than among those with no exposure. So we can say that coronary heart disease is 1.61 times more likely to occur among smokers, to suspect among smokers than among those with no smokers. So we can interpret by this way: the larger the value of relative risk is, the stronger the association between the disease and the exposure. So when the relative risk is becomes larger, there is strong association between the smoking and coronary heart disease. That means now the relative risk what we have get is 1.61. So 1.61 is as much not strong. To be strong, at least it more than 3. So now this is almost moderate type of association. Coronary heart disease, cigarette is moderate type of association. So this is, and the other is values if relative risk close to 1 indicates that the disease and exposure to the risk factor are unrelated. Meaning when the relative risk becomes 1, there is no association. But it becomes too much narrow to the 1, that is the association between disease and exposure is became unrelated. So values of relative risk is less than 1, it indicates a negative association between a risk factor and the disease. That means the negative association between risk factor and the disease, that means it is protective. That means as the risk factor increases, the disease probability or the disease occurrence decreases, so that it is protective. So less than 1 is protective. But if greater than 1, if relative risk is greater than 1, it is a risk factor. As the disease increases, as the risk factor increases, the amount of risk factor increases, the disease occurrence will be increases. That means it's a harmful relationship. So don't forget this one. The other is in general, the strengths of association can be considered. There is strong association when we say strong association if the relative risk is between 3 above 3 is, we can say strong association between risk factor and disease. If relative risk is from 1.5 to 0.9, we can say moderate association. So the relationship between smoking and coronary disease 1.61, so it lies between this, so we can say moderate association is present. And if relative risk is from 1.2 and up to 1.4 is, we can say weak association. But if relative risk is below 1.2 and it is approaches to 1, we can say there is no association, or the association between exposure and outcome is unrelated. So if it is 1, there is no association between exposure and exposure and disease or outcome of interest. So this is a very important concept. So this will work also for odds ratio. So it's very important graph is this one. Relative risk, what happen if relative risk less than 1, if relative risk is 1, if relative risk is greater than 1. Risk comparison between exposed and unexposed individuals. Risk for disease is lower in the exposed than in unexposed. So the risk for leading disease is lower in the exposed group than unexposed group. So that means risk of leading disease for an exposed group is lower than in unexposed group, so it is protective. So risk of disease is equal to risk of disease equal for exposed and unexposed. For exposed and unexposed, that means if risk is equal, there is no association. The other relative risk is greater than 1. Risk for disease is higher in exposed than in unexposed. So this is risk comparison between exposed and unexposed. Exposure as risk factor for the disease. When we say exposure as risk factor for a disease, relative, when there is a relative risk less than 1, exposure reduces disease risk. Exposure reduces disease risk. So it is a protective factor. Relative risk is equal to 1. A particular exposure is not risk factor. Particular exposure is not a risk factor, not risk factor in this case. But relative risk greater than 1, exposure increases the disease risk. That means it's a risk factor having harmful relationship. That means as exposure increases, the occurrence of disease also increases. That means if you make more in dose and in frequency, if you are more smoker, or if you are smoke more daily and in much amount, so the risk of developing coronary heart disease will be increases. So this is a direct relationship between exposure and the outcome or the disease. So this is a good concept. So this is more about the relative risk. So we have seen the interpretation and the calculation. Now the second group is odds ratio. Odds ratio in case control studies, it is usually not possible to calculate the rate of development of disease in exposed and non-exposed group. So since we cannot calculate the rate of development of the disease, we will use odds ratio. So hence it is difficult to calculate relative risk. Relative risk cannot be possible. So relative risk can be estimated, however, by calculating the ratios of odds, of exposure among the cases to that of among controls. This is odds ratio. Now we will calculate the ratio of odds of exposure among cases, that of among controls. So this is odds ratio. So odds, what is odds? Not proportion, but the ratio of the number of ways an event can occur relative to the number of ways an event cannot occur. So odds means the probability of an event occurs over the probability of an event not occurs. That means event occurs over event not occurs, meaning P over 1 minus P. So P over 1 minus P, or we can say the probability of event occurs over the probability of that event not occurs, is called odds. So P over 1 minus P. So now odds ratio is calculated based on odds. So odds of cases being exposed, odds of control being exposed is known as odds ratio. So we can odds of cases being exposed. So we will use this calculation formula. The odds of control being exposed is the same thing. So this is for odds ratio. Now we will see based on the example and how to formulate the formula. So this is cases or diseased. This is controls which have not diseased. This is exposed. This is not exposed individuals. So we can give A, B, C, D. So odds ratio is the ratio of the odds that case was exposed to the odds that control was exposed. Odds ratio is odds that case was exposed, odds that control was exposed. So odds that case was exposed means A over C. Odds that case was exposed means this cases that was exposed means A over C to downward, A over C. And also odds that control was exposed means B over D. B over relative risk we have seen just like this, A over A plus B, C over C plus D. But in case of odds ratio, A over C and B over D. So we can say A over C over B, A over C over B over D, B over D. If you are reverse it, we can say we can get AD over BC. AD over BC is a formula for calculating odds ratio. So odds ratio means A over C B over D is equal to A over C times D over B. So that means AD over BC. AD over BC is formula for calculating odds ratio. So we can that AD over BC. So an example is use of artificial sweeteners associated with bladder cancer. So this is cases, this is controls, this is ever used, not ever used, this is exposed, this is not exposed. So exposed one is cases which is exposed is 1293. So this is numbers given. So the total is 3,000, 5,000, 3,000 and 776. So odds ratio can be calculated. So 1293 times 3,321. So over 2,455 times 1,707. So this is just like this and just like this. So the odds ratio is now 1.03. 1.03 is the odds ratio. So the odds that those with bladder cancer had used artificial sweeteners is 1.025 times greater than those who do not have bladder cancer. That means as we compared in contrast those with bladder cancer and those with no bladder cancer. So individuals who have used artificial sweeteners is greater by 2.05 to 5 in those who have bladder cancer. So this is the odds ratio. So the strength of it shows the strength of association. So now meaning based on the given it is greater than 1. So since it is greater than 1, it has a direct relationship between using artificial sweeteners and bladder cancer. That means it's a risk factor, but even if it is too much weak. Interpretation, if odds ratio is 1, so the exposure is not related to disease. Meaning there is no relationship between exposure and disease. If odds ratio is greater than, exposure is positively related to disease. That means they have positive or direct relationship. So the risk factor or exposure is will lead the outcome. The other is odds ratio is less than 1, then exposure negatively related to disease. So this is all. Now we will go to interpretation. So the odds of having the disease in question are odds ratio times greater among those exposed to suspected risk factor than among with no exposure. So we can say in this case the disease is bladder cancer. So artificial sweeteners is a risk factor. So this is the odds of having bladder cancer are 1.03 times greater among those who used artificial sweeteners than among those without used artificial sweeteners. So we can interpret by this way. For rare diseases that is prevalence less than 10%, odds ratio approximates relative risk. So like rare disease, when there is a rare disease or when the prevalence is low occurrence, in that case the value of odds ratio and the value of relative risk becomes approximate or becomes equal or nearly equal. So when is odds ratio good estimate of relative risk? If the incidence of the disease is low, then A plus B is approximates to B, C plus D is approximate to D. So that means A plus B is B, C plus D is D. Therefore relative risk means, as I told you before, A over A plus B, C over C plus D. That means we can replace A plus B by B, C plus D by D. So we can get A over B, C over D. This means A over B, C over D means equal to AD over BC. AD over BC means is equal to odds ratio. So in the case of the disease incidence or the disease prevalence is low, the value of odds ratio and the value of incidence rate becomes equal. So this is the one example. So for you to this, for instance, in this case exposed is 200, non-exposed 100. So this is exposed in the not developing disease 9,800. This is 9,900. So this is total. So if you want to calculate relative risk, you will get it 2. If you calculating odds ratio, you will get 2.02 means almost 2. So this is almost equal. So because incidence or the prevalence is almost low. So this case that means on low occurrences odds ratio and relative risk almost equal. So the next chapter is attributable risk. So in the next video we will show you about we will discuss attributable risk 80% and population attributable risk is 80%. So don't forget to subscribe this channel to get the next videos. Have a nice time. Bye.